So now let's talk about lake drainages. Super important stuff because as like a big storm, lake drainages, when they happen, can introduce a lot of water into the glacier at once. So yeah, those are just like videos of photos of lake at the different times in the year. We have here in winter, I think it's in Norway, and something happened because in summer, that lake is much smaller. And actually, you can see the marks and how high it was during the winter. So let's consider a normal discharge from a subglacial drainage system. That's the picture of a glacier. As you can see here on the bigger picture, there is a lot of water that is going basically through one single point. That's what we call a proglacial stream from the subglacial water. So we are around the middle, the end of the melt season. As I said, we have a channelized drainage network, meaning that most of the water in this that falls on this glacier is being drained through one main stream that we see here. So sometimes if you look at the streams, you can have what we call outburst floods that are sudden release of massive water around the reservoir that is stored somewhere around the glacier. And that somewhere can be a lake that is close to the glacier, on the glacier, or within the glacier. So subglacial, supraglacial or unglacial lake, or just something on the side that eventually drains into the glacier. And they can create those hour-long events sometimes, yes, and maybe sometimes even minutes-long events. So let's consider that draining lake. We have here in red the water level of the lake. So we go in time at some point, whoop, that water level falls, meaning that the water is going somewhere, it's leaving the lake. The lake is emptying. If we look at the discharge from the glacier, which is the amount of water that's exiting here, we have a peak of discharge at about the same moment the water level in the lake is falling. So basically we are transferring the water in the lake through the glacier, and all of that reaches the exit of the glacier. That's why the discharge is going high, it is increasing a lot, and then slows down because there's nothing else to drain. And the water in the level that is below the glacier, so that lake around that lake here, we are measuring also the level, the height of that lake. That is going up as we transfer the water from the lake that is above the glacier, around the glacier, to the lake that is below the glacier. So there are two lakes in that story. Those outburst floods can be big hazards. Some places of the world, especially I think in the Alps, some of these lakes would break and destroy complete villages, killing hundreds of people. That happens when you have a lake that is basically being dammed by the ice somehow. At some point in the season, it reaches a point where the ice is maybe not strong enough to hold that water, and the water in the lake breaks through the ice, and that's why you have such events that can happen. That was something they had to take account of when they built the Trans-Alaska pipeline, especially for the Taslina River crossing. Those lake outburst floods are kind of regular. If you go to McCarthy, for example, we always expect that to happen at some point during the year. There's a cool lake there that's called Hidden Lake. It's on the side of the Kennecott Glacier, and it grows during the melt season because all that snow is kind of falling into that lake, or that's melting, or that snow is melting, and that water is going into that lake. And at some point, that lake has enough water that it breaks through the ice and then reaches the exit stream of the glacier and increases the discharge of the river by a lot. And that's the exact same thing for this Trans-Alaska pipeline. When they built it, maybe the stream was pretty small, but they knew that it could grow by an order of magnitude whenever a lake is outbursting, and they had to account for that. So small quiz prep. Glacier outburst floods can occur from. I'll leave you a few seconds to answer that. So glacier outburst floods can occur from rapid surface melting in the summer, from groundwater sources under the glacier, from the rapid release of water reservoir at higher elevation, or from calving events. The right answer here is answer C, from the rapid release of water reservoir at higher elevation. Indirectly from answer A as well, kind of. It's not because the discharge is increasing that it means that it's a flood. A flood is really a whole lot of water, dangerous amount of water that's being released at once. But let's say you have a very warm, not day, but a few days, maybe a week of a lot of a very warm week, sorry, and you're melting a lot of snow and ice, then that is probably going to accumulate in a lake that eventually is going to release at some point. But the correct answer here is outburst floods are due to rapid release of water reservoir. Groundwater sources under the glacier, I don't think that has ever happened, because usually groundwater sources are a bit more steady in time, so the water would kind of, go by itself. Calving events just have nothing to do with outburst floods. Another question: what will happen to the ice velocity of a glacier if a large lake suddenly drains to the bed? I'll give you a few seconds. And the correct answer for that one is answer C. Basal sliding will increase. Why? Because, well, you're just putting a whole lot of water beneath the glacier. So the basal sliding increases and the glacier goes faster. Internal deformation rates will increase. No. Internal deformation rates will decrease. No, because it doesn't really have anything to do with the outburst. Basal sliding will decrease. No. But it's kind of a tricky question. I could ask this question as how would basal sliding evolve throughout a lake drainage? And what you might have is the lake draining and increasing the basal sliding a lot because there's a lot of water beneath the glacier. But like that storm event that we saw on the glacier I was studying, maybe that was enough to transition from distributed to channelized drainage network. So what you could have is the scenario where you have a lake that drains, the basal sliding increases a lot, and after that lake has drained, the basal sliding will decrease and eventually reach levels that are lower. You will have less basal sliding than before. That could be a case, but if that was an exam question, I would definitely be more precise in my question. And I'll see you in the next video.